it feels like just 5 years ago it was like 5G and RF, and now it's totally shifted to miniaturization and packaging and these kinds of areas. Do some of these issues become, or the most common design issues I say, become different when you start looking at the HDI and UHDI versus conventional fabrication?
So some of these, even though we call them errors, are not actually errors. They're more of the board not being designed to either A, meet the appropriate specification of performance requirements, but more importantly, the technology involved with the board. And to give you an example of that, for example, is, we kind of talked earlier about, well, your pad size for a class 2 versus class 3 versus class 3A would be different. Well, you can't take that as the global.
Hello, everyone, and welcome to the Altium OnTrack Podcast. I'm your host, Zach Peterson. Today, we are talking with Mike Tucker, Director of Engineering and Technology at Millennium Circuits. If you've seen the PCB West conference program this year, you know that Mike will be speaking at PCB West and, of course, working at Millennium Circuits. He's working at a manufacturer, and I always love talking to folks who work at manufacturers. Mike, thank you so much for joining us today.
A pleasure, Zach. Thanks for having me.
Absolutely. So you have not been on the podcast before, and we've never had anyone from Millennium Circuits before. So if you could, just tell us a bit about yourself and about Millennium Circuits and what you do at the company.
Okay. To bore you guys a little bit with about me, I've been building circuit boards now for 28 years. Worked in a lot of smaller, higher technology shops, mainly in front-end engineering and process engineering. Did a lot of work with implementing mil-spec, AS9100, et cetera, and have an extensive background in computers and software development to help drive automation and such to help take these higher technology products that we're trying to release to manufacturing a lot quicker to support domestic quick turn technologies.
So with Millennium Circuits, you're a US-based company. Are you producing only in the US? Are you also producing overseas? I asked because you mentioned, I think, mil-spec.
Yeah, so we are a PCB supplier that simplifies the production of complex PCBs to increase your speed to market. We manage a global manufacturing matrix, acting as an extension of our customer's team, if you will, to streamline quick-turn prototypes, solve complex technical issues, for example, or design for manufacturability, which is a ever ongoing topic. And we consistently deliver reliable PCBs on time. So we do that on a global level.
Okay. And then what is one of the biggest, I guess, challenges that clients deal with when they are trying to scale into a global footprint for manufacturing?
Usually, if you're trying to scale, it's going to be communication can be a challenge. Obviously, there's a language barrier there. Time delta, it can be an issue, as well as a lot of times, as you're obviously aware, not everybody words things the same or has a standard format for how they word notes or how they set up data to achieve the result that they want. So that can be a challenge as well in a global world.
Well, I can imagine that creates some common errors that you've seen over the years. And maybe this is a good segue into your presentation at PCB West. This year at PCB West, I know you're going to be on the stage with Ray Fugit. Maybe if you could just tell us what you'll be talking about, what's in your presentation and what people can expect.
So Ray and I actually go way back to the beginning of my career when he was with Advanced Cam Technologies and such, and I was just a little 19-year-old, bright-eyed, wannabe engineer programmer. So we've always, had a relationship and stayed in touch with each other over the years. And Mike Buteau had actually suggested this concept to Ray and Dave Hoover. Based on Ray's experience as a product engineer and Dave's experience as a process engineer at Hadco. Dave and Ray were the first ones to touch the data typically when it came into Hadco, and they had to resolve various issues prior to manufacturing. For myself, I had done many classes and presentations over the years, all over the world, and talked about a lot of this stuff in the front end, engineering, things going on with manufacturing. And so Dave and Ray thought that it would be a great addition to their seminar, and many times had invited me to come join them on several occasions. And Dave Hoover announced that he was stopping the whole trade show circuit, and so Ray and I joined forces, and I've offered my unique perspective on the PCB front end engineering and issues that's seen on a daily basis to complement the already great presentation line.
So it sounds like from your presentation, you're going to be looking at design errors that are common in the design package, but then are you also going to be looking at the manufacturing package and kind of where the two start to butt heads?
Yeah. So we kind of go through, there's like the top 10, top 11 reasons why, issues seen in manufacturing or in data packages, and it keeps evolving, over the years. And so we talk about all of that. A lot of things that designers and customers don't know that have to happen just to get product to the floor. It's not as easy, just import, hit a button, magic happens. So we go into those things, and we also touch base a lot in challenges of manufacturing and implications of maybe some fab notes or practices that they may or may not do, trying to offer as much insight and valuable information as possible within a 2-hour period.
I can already imagine, just based on the mistakes that I've made in the past, what the common issues are, and maybe some of the reasons that you have to go back to the customer with a query, or that you have to manually touch all the production data yourself. So maybe I can guess, and you can tell me if I'm correct or incorrect. I can already imagine one of the common errors is going to be inconsistency between the fab notes and whatever was put on a quote form, or whatever the original query was from, let's say, from the designer or the designer's company.
That does rank up there as some of the situations that we will see. For me, from early on in my career, I realized that the two critical components to build a successful circuit board, and let's face it, if the board isn't good, nothing is good, right? Being the front end engineer and the designer are the two critical components to this whole equation. And if front end engineering, if we're not right, nobody is right. You can build the most perfect board, perfect yields, etc. But I always felt it was the biggest disconnect, and there were so many layers. It felt like there were so many layers between communicating to a designer, whether that be going through the buyer, going through a CM, etc. And so with that, we started trying to engage designers more to educate them as a part of like my process, if you will, with my engineering teams over the years. A lot of things that you'll see that, believe it or not, I believe the biggest one are engineering change orders for granted deviations, or a proper ECM process. For me, it's the major recurring one that just keeps happening over and over and over. Countless times myself or my engineers have had to ask for the same deviation on numerous rev changes of a part. I've seen rev changes where just a component was moved, yet you have to get the same deviations for the new revision. It's a new contract, it's a new PO. And another challenge with that is once you design the board, like where is it being built? What if it was second sourced? Are the same changes or deviations granted, are they also happening at the second source, or etc.? So that's the major one that I see.
And with engineering change orders or deviations, I can imagine there's a secondary problem or challenge there, which is tracking all of that. Because at some point you might have to trace back through all of that. And I think for clients, they usually just rely on the email chain. I don't even know what the manufacturers are doing, if they're compiling everything into a document or a spreadsheet or what's going on there. But I have seen some of those email chains, and I've frankly created some of those email chains through my own mistakes, and they can get pretty hefty and almost impossible to navigate.
And not to mention, I don't. I like to say it. Not all board shops are created equal, and by that, not the practices. And some shops will question some things as others will not question certain things within a design. And then you also wonder, a lot of times in the quick turn world, you're trying to just hurry up and get the job to the floor. So sometimes, may have to make some decisions on the fly to get the lead time. And is there a proper feedback loop for that? Some shops practice that, some don't. And then my favorite always is, you bring a problem or a situation up to a customer or designer, and they'll say, well, my current supplier or other supplier hasn't questioned this or doing it with no issues. Why can't you do it? And I always repeat back to them, well, how do you know? And it's there's usually a long pause after that of oh, and not just simply say, we're trying to make sure you get what you think you're getting, and also bring you awareness so that you can make proper changes.
I guess the implication of that is that maybe this other supplier that you were working with just made the change for you and didn't tell you about it.
Very well could be, or maybe they didn't,
or maybe
they just let it go, and maybe there's some some liability, or not liability, but reliability potential problem facing that board due to not making the change.
Yeah, and I think quick turn world, those decisions, like you say, are a little different than moderate or high volume. One of the reasons being that quick turn doesn't always have the best yield, but at the end of the day, you got your 10 boards that you ordered and you got them in 48 hours or whatever, and so you're happy. You don't care if they had to build 15 of them and 5 didn't work.
Yeah, it's hey, I can take and stack a 50-layer board up and run 50 panels of it and get one to electrically test good. That doesn't mean I can build 50-layer boards, right? But that's one of the challenges of trying to take jobs from prototype to production. Is a lot of times prototype is I don't know. I like to affectionately call it run what you brung in many cases. So are we trying to get fit, form, or function, or is this a validation to prove it works and go on much larger scale? That feedback loop of any changes may not exist in those situations, for sure.
So at the end of the day, all of this originates somewhere in a PCB design file, and somebody did something in the design file that created this problem, whichever problem you're talking about. So what are some of the most common errors that the designer makes on the front end that then leads to some of these PCB fabrication problems?
I say a lot of items come from implication of your fab notes, your fabrication notes. You speak with many people of, where did you get these fab notes? Some people are, I don't know, it's just, we just copy and paste it from a Word document, right? Well, how, do you understand how that the words in that Word document, how they affect, what you've laid out in Altium in this case, right? So how do they play with each other? Do the words support that? I think a lot of times over the years, I've seen that auto router just go crazy with some things. Maybe you have two SMD pads a certain distance from each other, and you say, my minimum routing spacing is going to be 5 mils. Well, let's say there's 15 mils in between those two SMD pads. It'll say, let me just route it 5 mils away from this SMD trace, right? When you can drive a truck through those, why not make it a little bit more manufacturable? I see a lot of that. Copper balancing, low copper density areas and boards can be a problem. And I think overall, a lot of it is back in the days we had captive shops where, the designers, worked, at the shop, if you will, and could design the boards, and the boards were a lot less complicated back then. And that's since gone by the wayside. So I would say a lack of manufacturing knowledge is also a large challenge.
You brought up something interesting with the captive shops because we've had Happy Holden on in the past, and he kind of described the history of the PCB industry and how things ended up going offshore, and a lot of things ended up going into Taiwan. And he brought up that same point. A lot of the designers, they were working for a company that produced their own boards. Like if you worked for HP had their own board factory somewhere in the US. And so they either worked in the building next door to the factory, or they could at least go, on a trip from whatever office they were at and get a tour of that facility. And now I think you'll struggle to find designers who have really gone through a tour of the facility where they produce at, or even really any facility that's going to produce similar stuff to what they want to design.
Very true. I see not only that, but the fast evolution of things. For example, what's been a common theme this year has been Ultra HDI, things getting smaller and smaller, right? So what's being done in the design tools to support that, but more importantly, what is being done for the knowledge of it. Everybody loves to make it smaller. Oh, I can use smaller features, therefore I can escape route this in no time, right? But what's happening behind the scenes on this? Are you designing it? Now you have to face with, are you designing the class 2, class 3, class 3A? Is this mil spec? Those are going to have different design rule guidelines surrounding those decisions. So how are they playing with each other? Automotive. I feel like there's a lag between what's being put out in the automotive world and the performance requirements and acceptability requirements. There's a lag between that versus the actual output and development of some things that go in your vehicle. But again, even if those standards and such are there, how are people getting educated to those effects of, to the aspects of what they're doing with their designs and what needs to happen in their designs? 2221, for example, if you're doing the rigid, things on that side. Those are some other things I see.
Yeah, you brought up standards, and I think at least with like IPC standards, like 2221 and 6012 and 6018, there's enough decent guidance out there. Manufacturers have done a better job, but like you bring up something like mil-spec, or you bring up something like some of the automotive stuff. I feel like a lot of that knowledge is still really tribal, and if you haven't worked with somebody else who's done it before, you're going to kind of be poking around blindly, and hopefully you go to a CM that at least serves the automotive industry, because you could at least consult with them and get some guidance on, what are the design rules? How are we going to build this? What materials should we plan for? Those kinds of issues. That way you don't spec out something and complete the design, and then they tell you, well, we can produce it, but it's not going to meet this automotive standard or whatever the standard is.
And even for EMS and CMs, not all are created equal. Some do have skilled engineers that you can speak with that have some level of manufacturing knowledge, but for the most part, the key and critical component is getting access between the process engineering or front-end engineering of a board supplier and the designer. That's going to be the key component there. I've seen usually like EMS and CMs, they're going to have information regarding, hey, this array, or, this component needs to be twisted or moved this way, right? But as far as where the rubber really meets the road is what's happening on a board level. Those decisions, every mouse click affects yield, price, and lead time. Drives it significantly. And I, at least in my world, if you will, we try to get in touch with those designers and say, before you even open your CAD software, let's talk about what you're trying to do. And we've had great success with that. Worked with one customer who they just automatically do a 1+N+1 HDI solution with a blind via. Was able to work them into a through hole with non-conductive fill cap plate. You saving money over the life cycle of that board, or the life of that board versus recurring costs. Because a lot of times engineers, they don't know the implications. Again, implications of the fab notes or choices.
Yeah, and that's another one that I see pretty often among some folks, even in circles where like they're really talented engineers, but you start to ask them, well, why did you use split grounds, or why did you design this to have 3 lamination cycles when there's really no need for it? And I think it's more their comfort for how to use the layout tool rather than thinking about how is this going to impact what I have to do when I actually need to produce this.
Yeah, that can affect it as well. For sure. I do see that.
So we've talked so far about board fabrication, and like you say, right, if you get the circuit board wrong, nothing else matters. But at some point, you're going to have to put some components on this thing in order to create a real product. So what about assembly? What are some of the most common, let's say, design for assembly errors that you see?
So, from a board level, we're not too involved in, looking at, oh, this is definitely going to tombstone, for example. But we're not looking at that. But what we do see often is taking the time to get a true understanding of your board house's panelization rules to get best material utilization. Material makes up, anywhere from 30 to 40% of the cost of the board. So it's the biggest driver. So trying to understand that at a designer level, because if you understand a good panelization, the utilization rules surrounding that, what if you could change a board? Not always you can do this, but if the opportunity presents itself, what if you can make a small change in a dimension here or there, and that propagated ends up, increasing 5 to 8% or even 10% panel utilization. So it's key to understand things like that can happen in the background. So not only the relationship between the designer and the board house, but also working with the CM, understanding that those rules, those sizes, etc.
Yeah, I think one thing that sometimes happens too with PCBA production is there's a defect, and some assembly defects are linked back to what you do in the board as a designer. And of course, there could be a fab defect maybe that contributes to that. But at some point, the fab guys are pointing the fingers at the assembly guys are pointing the fingers at the fab guys. Everyone's saying it's everybody else's fault. And the designers pointing their fingers at everybody, saying, I just wanted some working circuit boards here.
I'm always used to front end engineering is the first finger pointed at. So you learn to see why. Hey, did you do this? Why did you do that? It's a life of scrutiny, if you will. But very much an accurate representation.
And then you brought up UHDI, right, or ultra to HDI, and yes, that kind of being, I think, the dominant theme this year. It feels like just 5 years ago it was like 5G and RF, and now it's totally shifted to miniaturization and packaging and these kinds of areas. Do some of these issues become, or the most common design issues, I say, become different when you start looking at the HDI and UHDI versus conventional fabrication?
So some of these, even though we call them errors, are not actually errors. They're more of the board not being designed to either meet the appropriate specification of performance requirements, but more importantly, the technology involved with the board. And to give you an example of that, for example, is we kind of talked earlier about, well, your pad size for a class 2 versus class 3 versus class 3A would be different. Well, you can't take that as the global. Now let's throw into the mix, let's say that pad size, now you have non-conductive fill cap plated vias. Then let's say you got a blind via with a non-conductive cap fill via. So adding more copper makes it the copper gets thicker and it's plated copper, so it's more difficult to etch. So these design rules change with that. So that's where a lot of it will come from. Is there's no one size fits most, if you will.
Yeah, I can see now where you start to get some issues with some conflicting requirements, right? Because someone might design to, let's say, class 2 or class 3, and they oversize the pad or whatever whatever feature they're working on appropriately. But then once you bring in some more complex component, like you just mentioned, cap and fill, now that requirement suddenly changes, and
Mm-hmm.
they did everything correctly in the design software based on how they had set up the rules. They just didn't account for the fact that, well, they have to do this additional step when they're dealing with cap and fill, or when it's a blind via versus a through hole via.
Right. Or even maybe the design that they have, maybe it yielded all that. But then the Fab Note said, oh, yeah, I want this to be class 3. So then,
Right.
and many times you'll see it's not uncommon to get deviations for, yes, this is going to be built and certified at class 3, except for the vias we need a waiver for class 2 annular ring or 90-degree breakout or 180-degree. That's not uncommon to see.
Okay, and then I can imagine this creates some issues when you're going into high volume versus prototype, because with prototype, maybe it's not noticed until, the last minute, but you can still make a judgment call and even give advice to the customer. Yeah, technically for, class 3, you need to do this, but we're going to make sure that this is class 3 anyways. But once you get into high volume, there's enough statistical process variation to where you're going to be much more likely to have defects if you don't implement that class 3 change immediately.
Right. And then if you think about it, usually by then, it's a lot of times too late, because who wants to redesign a board? After you
Yeah.
spent arduous hours, and say, you know what, let me just do file new and, do this over again. So, you're either faced with that problem or, yeah, when you go into mass production, you're just kind of winging it and hoping for the best, if you will, in many cases. And then a lot of times, whoever's building your prototype may not be building your production. So you can make things work in a prototype world. For example, if something's too tight or not enough room, you can build on 12 by 18 panels or 18 by 24. And the sweet spot is the middle of the panel. So with a lot of these tight jobs and registration, you don't have to maximize the number up, because maybe, maybe it's just a handful of pieces needed for the prototype order. So you can just kind of put boards right in the middle. Everything registers up nice. You get the stuff on time, pay the premium. Life is good. Then it goes mass production, and you got big 21 by 24 or even other panel sizes, and now things don't fit so well.
You brought up something interesting here, which is the location where you prototype is not always the location where you produce at volume. And I think, definitely true if you're going to a quick turn place. That's what they do, is quick turn, low volume, maybe some mix to it, and they're going to get you your boards quickly, and they may not have the yield, but it doesn't matter. You're already paying for a huge margin anyways, so, if you only have 80% yield, so be it.
Right.
Is there really, would you say there's a lot more benefit to doing that production of your prototypes and volume with a single company?
So that's a challenge. In that the advantage to it is many times the recommendations or advisements, especially if you make your supplier aware of it, can evaluate the job in that capacity, whether that be in a postmortem or whatever. But that may not satisfy requirements. Maybe, let's say, due to material availability, due to the material type you wanted. For example, maybe they can't, your production, house, maybe they don't source certain material sets that you're looking for or need. So it can be a challenge. Usually you're going to find that depending upon your situation. Asia can do it. And then here domestically in the U.S., there are a handful that can do it, but the challenge comes into if you want to run a large volume.
It sounds also like there's a little bit of a risk that the manufacturer has to take, because if they're probably making the bulk of their revenue or their margin on high volume, and if they're going to chance it with prototype, really at the end of the day, they're hoping that this prototype works out, and the customer is then going to say, okay, let's do 1,000 a month or something like this.
Yeah, and an odd phenomenon I saw a while during the great component shortage of the early 2020s was I still saw boards being ordered on quick turns, and that kind of struck me. I was like, well,
I did that.
It's a long lead time. Yeah, but if you got a long lead time on components, but you still have a delivery date, right, somewhere in there, and you know your shelf life for the surface finish is X, it's like, well, why not order on a 15, 20, 25-day lead time? But everybody always forgets about the board sometimes. But these things are incredibly complex with a lot of moving parts, so that happens.
Yeah, and I'm sure, like, as a producer, of high volume, you can definitely advise somebody when, okay, it's best if we do the prototypes, here are the reasons why. And I'm sure if you look at board complexity in volume production, you could say, we can help make sure that this prototype, once you get it designed, is going to easily transition into high volume. But I'm sure there are other products where you could say, listen, it kind of doesn't matter where you produce this. You might as well just, do some prototypes from China, get them assembled, and do whatever testing you need to do. And it's going to be so easy for us to transition this into volume for you that just find whatever prototype house works for you. Have you ever told that to a customer, or do larger manufacturers ever do that with customers?
Yeah, so I've seen situations where we help a lot of times where we can build a board domestically for the immediate need, but then start working the production side, right? But it's advantageous in many cases, especially with sequential laminations, et cetera. No matter what, there's there are little recipes and there's software you can use, but you want to be able to nail that scale factor down going to the floor as these things keep shrinking and shrinking with every bond cycle. You want to be able to have good registration out the gate. So a lot of times, depending upon that complexity, it's like, look, I understand you want it in 5 days, but it's probably going to be better in the long run just to take this approach, hang out for a couple more days. And, we can do like a 1 or 2 day air from Asia for you for some protos, just with a couple extra days.
Okay, I think that's an appropriate approach in some cases. And at least it's, at the end of the day, it's serving the customer with getting them to their goal of, producing at volume, at quantity, with high quality, minimal defects, minimal rework, all of that.
Right. And that's kind of what spawned this whole prototype world, at least in my experience of this industry. Is the U.S. definitely became the rapid prototyping, right? I need it fast. You look at it like a lot of the automotives, every 3 years, they're tweaking them, an F-150, it's going to be built this way 3 years. Then they start, changing stuff, and they're already planning for that. So all this stuff is happening fast. They're trying to design it fast, build it fast, and then figure out, okay, how am I going to do validation testing on this? And what are the parameters, make sure everything is set up. And it's definitely caused a lot of disconnect between that prototype and production world of, it's getting more and more complex. And these things become far more important to, if you will, take your time with, but time's getting smaller and the boards are getting smaller.
Yeah, that's all true. Definitely. So as we said earlier, you're going to be at PCB West with Ray Fugit. Which day are you going to be speaking?
It will be the day of the show, October 9th.
Wednesday, October 9th. Okay. Mm-hmm. This is a free session?
Yes.
I'm going to be there at the exhibition on Wednesday, October 9th. I hope our listeners will also show up to the exhibition and make sure to catch Mike Tucker and Ray Fugit at PCB West. Mike, thank you so much for being with us today. To everyone that's been listening, we've been talking with Mike Tucker, Director of Engineering and Technology at Millennium Circuits. As I mentioned earlier, make sure to head over to PCB West on October 9th. You'll be able to catch Mike Tucker and Ray Fugit giving their presentation day of the show. If you're watching on YouTube, make sure to hit that subscribe button, hit that like button. You'll be able to keep up with all of our tutorials and podcast episodes as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.